Hi, good evening. This is Dr. Abdul Rahim. Hope you are all doing well. So, today we are going to discuss a new topic from the linear algebra, which is called solving the system of equations by using the Gaussian Jacobi method. So, what is this Gaussian Jacobi method and when it is used? So, Gaussian Jacobi method is used to solve the system of equations when the given system is diagonally dominant. So when do you say that the given system is diagonally dominant? Let us solve one problem by using this method. Okay. So solve the given system of equations. 14x1 minus 3x2 is equals to 8. x1 plus 5x2 is equals to 11. So this is equation number 1 and this is equation number 2. So now if you see these two equations, the first equation number 1, the coefficient of x1 is 14 and the coefficient of x2 is minus 3. So among these two coefficients, so the x1 coefficient is the big one. Now if you see the second equations, the coefficient of x1 is 1 and the coefficient of x2 is 5. Among these two coefficients, the x2 coefficient is the biggest one. So now here in the equation number 1, the coefficient of x1 is bigger, and in the second equation, the coefficient of x2 is the bigger one. So here, so 14 and 5 are diagonal. So therefore, we say that the given system is diagonally dominant. So when the given system is diagonally dominant, we use the Gaussian Jacobi method. So how do we solve it? Let us do it. Okay. So now from the given equation number 1, so we have to find the value of x1. So from the given equation number 1, we have to find the value of x1. So if I want to find the value of x1, I have to move this term to the right hand side. So it becomes 8 plus 3x2. So now the coefficient of x1 is 14. So I will divide by 14. So I will get the x1. So this is equation number 3. Okay, so now from the equation number 2, we have to find the value of x2. So if I want to find the value of x2, I have to move this x1 to the right hand side. So it becomes 11 minus x1. So coefficient of x2 is 5. So dividing by 5, we will get the x2 value. So there, from 1 we get x1 and from 2 we have to get x2. So this is 3 and 4. So now procedure for solving it. Okay, so we will take the table. So we have the first column as variables. We have first iteration, second iteration, third iteration, and fourth iteration. So now in the variables, so we will write down x1 and x2 value. So we have x1 and x2 from 3 and 4. So x1 is equals to and x2. 1 by 14, 8 plus 3x2. So x2 is equals to 1 by 5 into 11 minus x1. So this is from this equation. Now, for the first iteration, what we have to do? So for the first iteration, we have to substitute the values of x1 and x2 on the right hand side. On the right hand side. So here we have to put x2 is equals to 0. And here we have to put x1 is equals to 0. So then if I put x2 is equals to 0 here, so the first iteration is, so x1 first iteration is equals to 1 by 14 into 8 plus 3 into, instead of x2 I have to put 0. So therefore 3 into 0 is how much? 0. So 1 by 14 into 8 plus 0 is 8. So 8 by 14 is equals to 0.571. Similarly, so to get the first iteration of the x2 variable, what I have to do here in this, I have to put instead of x1 0. So therefore 1 by 5 into 11 minus 0. So 11 minus 0 is 11. So 1 by 5 into 11 is 11 by 5. So we will get, on simplifying, we will get 2.2. Okay. So now the first iteration, we have the x1 as 0.571 and x2 as 2.2. So now we have to go for the second iteration. So in the second iteration, we will use the same equation only, but we will substitute, instead of x1 and x2, we will substitute the values of the first iteration. So therefore, same equation, we have to take the same equation, but since we are doing the second iteration, we have to take the values of x1, x2 from the first iteration. That means x1 will be taken as 0.571 and x2 will will be taken as 2.2 in this equation, right? So therefore, same equation, x2 is equals to 1 by 14 into 8 plus 3 into x2. Instead of x2, we have to take the values of the from the first iteration. So instead of x2, we will put 2.2. So that is 3 into 2.2. So 1 by 14 into, on simplifying this one, so we will get 1.04. Similarly, x2, same equation, but here instead of x1, we will put the value of x1 from the first iteration, that is 0.571. So therefore, x2 is equals to 1 by 5 into 11 minus, instead of x1, we will take 0.571. So now on simplifying this one, we will get the value of x2 as 2.085. So now let us go for the third iteration. So for the third iteration, so same equation we have to use, but we will use the values of an x1, x2 from the second iteration. So that is what we have to remember. So therefore, so 1 by 14 into 8 plus 3x2. So 8 plus 3 into, instead of x2, we have to take the value from the second iteration, that is 2.085. So now on simplifying this one, we will get the value as 1.018. Similarly for the second variable, so same equation, but instead of x1, we'll substitute the value of x1 from the second iteration. So that is, so therefore 1 by 5 into 11 minus, instead of x1, we will take the x1 value from the second iteration, that is 1.04. So therefore, on simplifying this, we will get the value as 1.99. So now let us go for the next iteration, that is fourth iteration. So x1, value of x1 is equals to same equation, 1 by 14 into 8 plus 3x2. So 1 by 14 into 8 plus 3 x2. So instead of x2, we will use the value of x2 from the third iteration. So that is 1.99, 3 into 1.99. So on simplifying that one, we will get the value of x1 as 1.081. Similarly for the x2, same equation. So 1 by 5 into 11 minus x1. So 1 by 5 into 11 minus. So instead of x1, we have to use the value of x1 from the third iteration, that is 1.018. So on simplifying, then we will get the value of x2 as 1.99. So now, if you see the values of x1 and x2 from the third iteration and fourth iteration, we have the same values. So x1 is equal to 1.018. Here also x1 is equals to 1.018. x2 is equal to 1.99 and x2 is equals to 1.99. So here we will stop the next iteration. We will stop here. So now as the values of an x1, x2 from the third iteration and fourth iteration are repeated, so we will stop here, and the solution of the given system is x1 will be taken as 1 and x2 will be taken as 2. So these values are rounded. So that is the procedure for solving the system of equations by using the Gaussian Jacobi method. So we will use this Gaussian Jacobi method to solve the system of equations which are diagonally dominant system. So right, so we will be doing the iterations until and unless we will get the consecutive same values for the same variables. If we get the same values, so then we will stop the iteration and we will write down the solution for the given system to the nearest value. So it is rounded. So therefore here x1 is rounded to 1 and x2 is rounded to 2, right? So thank you for watching my video. If you like my video, please hit the like button, kindly share it, and as well as subscribe to my channel for watching more videos. Thank you.